Hello guys, welcome back. Are few months that I am working with neural network, and the first thing that I did was to implement, as you know, the tic-tac-toe game using the fully connected neural network and using backpropagation. But then I saw that this approach for game AI and also dynamic learning is not so good. So I started to search for another way, another approach that allow me to attach the neural network to something like a game. And then I discovered the neat approach, the neuroevolution of augmented topology. This approach is really good in this scenario. And thus, what I did was to start implementing the neat algorithm and then implement the Pong game. So, this is Andrea, and today we will discuss about Pong AI. I think that you already know that the neat algorithm, the neat approach, has a population with a lot of organisms, and each of these organisms must be rated, must be assessed. So one of the first challenge that I was facing was find the proper equation in order to assess the organism. And one of the first idea was to give a higher fitness when the player hit the ball. But turns out that this solution was not so good because imagine that initially the organisms are not able to play the game, does know nothing about the game. So how they can really hit the ball? And I saw that the neural network was not able to learn much and doesn't learn from the start. So what I did was to add an equation that takes care of also the distance of the ball relative to the player. And turns out that the neat algorithm was able to takes all the organisms that were able to follow the ball, and in 20 epochs more or less I found a champion that was able to, we can say, play the game. But then the fitness was not perfect. In fact, what I figured out was that after about 20 epochs there were no more advances. So the idea was to change the equation in order to rate the player when they hit the ball, but with an exception. When the player hit the ball for the first two times, the fitness added is really tiny, really small. Instead, when they start to hit the ball after these two times, so for example the first or the fourth time, the fitness added is really high. And this is why, because in this way I am able to discard the first two hits because could be made just for luck, and then assess really the player and give a really good fitness to the player that are really able to hit the ball. And this equation was really nice, and I was able to step forward. By changing the inputs, I can have also different outputs. And so, worth discuss about the inputs that I was feeding inside the neural network. The first idea that lasts for just 5 minutes was to feed the neural network with a lot of data. In fact, initially my idea was to feed all the information like the player, the opponent position, the ball position, the ages of the table in pixel data. So the idea was to have around 5,000 neurons, but then I discarded this idea because, as you can imagine, have 5,000 input neurons means that in order to the neural network figure out how to really play the game, it should have around 20,000 hidden neurons. But the problem is that with the NEAT algorithm, it requires ages in order to spawn 20,000 hidden neurons, and so I discarded it immediately. The second idea instead was to create kind of grid attached to the player that move with the player, and this grid, when the ball enter inside this grid, all the pixels around this grid became highlighted, get the number 1 value, and then I feeded all this information inside the neural network. As you can imagine, I had around 700 inputs, and I can say that using this approach I was able to create an AI that was, yes, able to play the Pong game, but was not really precise. There were situations where the ball, where the player can't catch the ball or doesn't know what to do, and other situations when the AI was really nice. And so I tried to leverage to fix this problem by changing the resolution of the grid, by changing the dimension. And I also created a grid with just one row, but turns out that this solution was not so nice, and requires again a lot of time in order to improve the neural network. So what I did was to minimize the input at most, and then I fed just 5 neurons. The first 2 neurons was the position of the ball relative to the player, normalized. The second 2 was the velocity of the ball, normalized, and the last one was just the bias, that is always 1, as you know. And after around 20 epochs, the neural network was able to play. It figured out how to play. And I can say that after 100 epochs, the AI was really tough, and I was not more able to beat the AI. So the conclusion of this month of programming of the neural network is this one. The NEAT algorithm, the NEAT approach, is really nice when you have not a lot of inputs to feed inside the neural network. And this because you have to know that the NEAT approach is really tied to the random thing. It is the randomness that decides if a mutation should add a link or should add a neuron or should change all the weight inside the neural network. And as you can imagine, when you have thousands of neurons, it's difficult for something to develop the proper shape, the proper weights in order to make something to work, to play. And it requires a lot of time. I think that the NEAT algorithm with a lot of inputs doesn't work really well, and there are other approaches. But one thing to say is that not a lot of input neurons, the NEAT approach is really shiny, because it is able to figure out how to play the game in a really fast way, and also by searching the optimal topology of the neural network. I have created the Pong game. You can download it on itch.io, or you can compile it, because everything is open source. So let me know what you think in the comment, and I bet you to beat the AI, but not the champion one, but even the monkey. Let me know if you are able to do it. See you in the next video, and bye bye.